Alright everyone, today's lesson is a review of linear and quadratic functions from Algebra II. Now today's lesson is actually just the linear review. The quadratic review will actually occur in a different video since that would be pretty long. So first, let's just review some properties of linear functions and think about all the things that you remember back from Algebra I and from Algebra II. Hopefully the first thing you remember, or something close, is that linear functions or linear equations have a slope, and we often denote the slope with the letter m. So if I was looking at this equation right here that I've got graphed, I would calculate the slope by rise over run, or sometimes the change in the y values over the change in the x values. So if I'm looking at the rise, I rise from point to point 2 units and I run 3 units. So the slope here is 2/3. If you recall, we also have a slope formula, which is y2 minus y1 over x2 minus x1. It's the change in the y's over the change in the x's, the change in the rise over the change in the run. Hopefully you guys remember, for a lot of y'all, the first way you were taught involved this point right here, which is the y-intercept. But it also has an x-intercept as well. So what we want to do is we want to review all of the specifics on these, like how we write lines, how we graph lines, and what are their unique properties. So first, let's review point-slope form. It's my favorite, and it's often not taught first, but it should always be taught first. So the point-slope form of a line is the easiest, because if you have a point and a slope, you're all set and you can write the equation of your line. So let's say the point is x sub 1, y sub 1, and your slope is m. Well then, point-slope form of the line is y minus y sub 1 equals the slope times x minus x sub 1. So you are inserting the point you have here and the slope you have here. So let's look at the example. It says, write the equation of a line that passes through the point 8, -3, and 2, 6 in point-slope form, and then graph it on the coordinate plane. So to find the slope, I'm going to find the difference in the y's, so 6 minus -3, grabbing those from right here, all over the difference in the x's, which is 2 minus 8. So this gives me 6 minus -3 is a 9, and then 2 minus 8 is a -6. So I have a slope of -3. Sorry, I pressed the button to go to the next slide. Okay. And now what I do, since I have my slope, I can use either point I want to write the equation of this line in point-slope form. If I use the point 8, -3, I'll have y minus a -3 equals -3/2 times x minus 8. And I would clean up this y minus -3 to y plus 3 equals -3/2 times x minus 8. And that's if I use this point right here. If I use the 2, 6, well then I've got y minus 6 equals -3/2 times x minus the 2. And there's no need to simplify anything there. Now to plot from point-slope form, you'd start with your point. If I start with the 8, -3, I'd plot that point, and then I need to generate a slope of -3/2. So I could go up 3 and to the left 2, or I could go down 3 and to the right 2. So there would be my line. Make sure you draw the double arrows because the line goes on forever. It's not a segment. Then, if I were using the other point, well then I'd go to the point 2, 6. 1, 2, 1. And again, I could go up 3 to the left 2, or I could go down 3 and to the right 2. Notice when I draw my line, it connects perfectly with my other one because they are indeed the same line, and it should not matter which point you used. As long as you have the right slope, you get the same line. Y minus 6 And if I look right here on my graph, indeed, the y-intercept is the 0.09. Good deal. X-intercept of 6 right here. Indeed, 6, 0. Halves. Oops. Not sure. So now let's look at slope-intercept form. This is probably the one you were taught first. So slope-intercept form is y equals mx plus b, where m is still your slope, and b is your y-intercept. And most people are taught this one first because it's the easiest to graph. Still not my favorite. So it says write the equation of the line from the last example in slope-intercept form. So if we go back to the last slide, you can remember we had equals -3/2 times x minus 2. That was our point slope form. We also had y plus 3 equals -3/2 times x minus 8. So in order to go from point slope to slope intercept form, it's really 2 easy steps. You're going to distribute on the right hand side to clean up and get rid of those parentheses. So I end up with -3/2 x plus a 3. Then I'm going to add the 6. So I've got y equals -3/2 x plus a 9. Let's go to the graph and let's take a look and see, does that y-intercept equal 9? Let's take a look at my other equation in point slope form because it's the same line, or it should be. So when I clean this up and I change it so that y is by itself and put it in this point slope intercept form, I should get the same thing. So let's clean this up. Again, it's 2 steps. -3/2 times x is -3/2 x. -3/2 times a -8, I'm going to end up adding, and I believe that's going to be a 12. And then I subtract my 3, and I get y equals -3/2 x plus a 9. So notice, good deal, got the same thing, like I thought I would, like I know I should. So one thing to note is if we have the point slope form of a line, there are an infinite number of points that are on a line, so you've got a lot of different options there. When you have slope intercept form, there's one slope and there's one y-intercept. So therefore, there's only one form of that line. Now let's talk about standard form, the underrated form. So standard form is ax plus by equals c, where a, b, and c have to be integers. So a little math notation. This means n, and this is the family of integers. A lot of people or textbooks say that the a value has to be positive, and while I think that's a preferred form, I don't know if that's necessarily the case that it has to be positive, but a lot of teachers will make you rewrite that, which is totally fine. You just do what they ask you to do. So here it says, write the equation of the line from the last example in the standard form. So going from that slope-intercept form, I had y equals -3/2 x plus a 9. So looking at the standard form and looking at the slope-intercept form, I noticed that the x is on the wrong side. I need this term right here to be on the other side. So I'm just going to move it over. It's negative, so I'm going to add it over to keep my equation balanced. Now I have 3/2 x plus the y equals the 9. And I'm writing the x first because my standard form has the x first. And now I'm looking at it and the bones are really good. The problem is the a value. So right now, the a is 3/2, the b is 1, and the c is 9. So the issue right here is this 3/2. I can't have 3/2 because it's not an integer. So how can I turn this thing into an integer? Well, I know I can do anything I want to an equation as long as I keep it balanced. So I'm going to multiply it. I'm going to scale it by a constant. And I'm thinking about a constant that would cancel out this 3/2 and get rid of the fraction. So looking at that denominator, I'm thinking I don't want that 2 anymore. So let's multiply by a 2. And if I multiply by a 2 to the first term, you just got to make sure that you're multiplying all the way through. So 2 times 3/2 is 3. So I end up with 3x. 2 times y is 2y. And 2 times 9 is 18. And I am all set. Now, my a value I've changed to 3, b value to 2, and my c, 18. Integer, integer, integer. I'm good to go. Now I want to notice also, I could scale this again by any number I wanted as long as I keep these all integers. Let's say I multiply all of these, I don't know, by 3, just for fun. I'd get a 9x plus a 6y. Now 18 times 3 gives me, can't do that one in my head, so I'm going to do 30 plus the 24, 54. Now this is fine too. Now you have your a is 9, your b is 6, your c is 54. Integer, integer, integer. I'm all good to go. If I were to take either one of these equations, the blue or the green, and I solve for y, I'm going to end up right back where I started. Remember what that was. It was 3x plus first slide. X and y intercepts. So that's a big idea with linear equations, x and y intercepts. So what I want you to think about is if I have a linear equation, if I'm looking at an x-intercept, where it crosses the x-axis, notice that the y value at that point is equal to 0. So when I'm trying to find the x-intercept, you're going to plug in 0 for y and solve for x. If I'm trying to look for the y-intercept, I want this point right here. Notice that x value is 0. So if you're looking for a y-intercept, you're going to plug in 0 for x and solve for y. So let's look at the example we've been working with. Why not? So let's do the standard form. It's not going to matter which one, but let's look at the standard form. But it would work with any of them. I can't 2y equals 18. I'm choosing this one because the numbers are smaller. So if I'm going to find the x-intercept, remember I'm going to plug in 0 for y. Should be a colon, not an exclamation point. And I'm going to solve for x. Well, here 2 times 0 is just 0, so I'm left with 3x equals 18. Divide by my 3, and I get x is equal to 6. My x-intercept is 6, 0. I should be able to go to the first slide and verify that. If I go back to the now I already know the y-intercept is 9. I know that because of my slope-intercept form. But let's go ahead and follow this algorithm to show. So I plug in 0 for the x. 3 times 0 is 0. I'm left with 2y equals 18. Divide by 2. And y is indeed equal to 9. And again, this doesn't work only with standard form. It works anytime, any equation. So let's write the equation of the line graph in point slope, slope intercept, and in standard form. So let's go through all three. So starting in point slope form, it's my favorite. You just need a point and a slope, and I've got an abundance of all. I think I'm going to use this point right here, 2, 2, as my starting point. I need to calculate the slope. So let's figure out the rise over the run situation. So it looks like I'm rising 1, 2, 3 here. And I'm running 1, 2, 3, 4, 5 to the left. So I'm going to have a negative 5. So my slope is 3 over negative 5. So point slope form, let's start there. is y minus my y value, which is a 2. It's that 2 right there, equals a negative 3/5 times x minus my x value, which is a 2. And there's my point slope form. All done. Now to get from point slope into slope intercept form, it is 2 steps. I'm going to distribute first that negative 3/2, giving me a negative 3/5 x, plus, this one doesn't clean up nice, it's a 6/5. Negative 3/5 times a negative 2 is a positive 6/5. Next, I got to add this 2 to the other side to get the y by itself. So I have y equals negative 3/5 x. Now this plus 2 right here. Got to get a common denominator of 5, which changes this to a 10/2. So I get plus a 16/5. Oops, there we go. Get rid of this tiny little thing. There we go. All right, and now finally, standard form. 1, maybe 2 more steps. I need the x on the other side of the equation. It's negative, so I'm going to add the 3/5 over. And I'm going to write the x first. So I'll have 3/5 x plus a y equals a 16/5. Check your a, b, and c. I've got an a of 3/5, so I know automatically that's a no-go. My b is 1, which is fine, and my c is a 16/5. So what do I need to do to cancel out that 5? Let's scale everything by a 5. So 5 times 3/5 is just a 3. So I have 3x plus 5 times 1 is a 5y. And then 5 times 16/5 is a 16. And there is my standard form. Just remember, all of these, same line. It's the line that's graphed right here. All the same thing. So now, down here it says, now write the equation of the line that is parallel to this line and passes through the point negative 5, 0 in point slope form. So remember, parallel lines have the same slope. They never touch because they have the same slope. So I'm looking for the line, point slope, parallel to this line, meaning it has the same slope of negative 3/5. But this one passes through the point negative 5, 0. I notice this is special. It is an x-intercept because the y value is 0. And they ask me to write the equation of the line in point slope form. So I'll have y minus my y value, which is 0, equals my slope, negative 3/5, times x minus a negative 5. Change this to a plus 5. And then they said graph it on the coordinate plane above. So if I'm graphing this, first I got to go to the point negative 5, 0. And now to generate that slope of negative 3/5, I can go up 3, left 5. Or I can go down 3 into the right 5. There we go. All right, so now it says graph the line that passes through the point 3, negative 2 and has a slope of negative 2. So let's go to the point 3, negative 2. Here it is, it has a slope of negative 2. So to generate that slope, I'm going down to right 1, or I'm going up 2 and left 1. And now I'm going to connect those dots to get that line. It says write the line in point slope, slope intercept, and in standard form. So now would be a great time for you all to practice, to pause the video, practice, and then come back and make sure all of your work matches mine. I'm going to work out the problems, but I'm actually not going to verbally talk about what I'm going to do.
Here, Mommy.
So now it's a good time for you to pause the video and then come back in just a minute. Okay, so now you can see my point slope form, my slope intercept form, and my standard form. And you have time to check your work and make sure that you are all good with how to go from point slope, slope intercept to standard. This one wasn't as hard because there weren't any fractions to undo. So now it says, now write the equation of the line that is perpendicular it's a new word, to the line above and passes through the point -4, 1. Then we're going to graph it. Okay, so remember perpendicular slopes. Sometimes we use this symbol right here for perpendicular. They have opposite reciprocal slopes. And so the slope of this line up here in the blue is -2. It's kind of hard to see. Slope is -2. So that means the slope of my line would be the opposite reciprocal, meaning it's a positive. Now this 2 is understood to be over a 1, so the reciprocal would be 1/2. So I need to write the equation of the line that has a slope of a half and passes through the point -4, 1. Well, point slope form makes this really easy for me. I just have y minus 1 equals 1/2 times x minus a -4. So I can clean that up to y minus 1 equals 1/2 times x plus a 4. So this line should be perpendicular to the line I've graphed here. Now we can go ahead and graph that line. If I go to the point -4, 1, and I plot a slope of a half, I'm going up 1, right 2, or I'm going down 1, left 2. Draw this line. I would need to keep this one going, so I generate some more points here on this line. You can see here we've got these lines that intersect. They have opposite reciprocal slopes, and what's special about them is when they intersect at a right angle, or 90-degree angle. So we have all of these angles are 90 degrees. Pretty cool. All right, so now this final piece of this question says, now find the intersection point where the two lines meet. So that point here in the green that I have in the middle, what is that point right there? You can see it's not going to be a pretty integer point. I can see it's lying in quadrant 1, so I know x and y should be positive, but it doesn't look like they're integers. So let's review your options here. You've got two lines. Line 1, I'm going to pluck the slope-intercept form. Y equals -2x plus 4. I'm getting that from right here. Line 2 is y minus 1 equals 1/2 times x plus 4. If you remember, you have some options here to find intersections of lines, and they were elimination and substitution. Sometimes elimination is called linear combination. And this one is just set up so nicely for substitution because I have y already by itself here. I've got y is equal to -2x plus 4. So what I can do is in the other equation where I see a y, which is right here, I'm going to substitute in -2x plus a 4. Once you do that substitution, you should see I've got an equation now that only has one variable with x's. And now it becomes an equation, a multi-step equation, where I can solve for x. So first on the left-hand side, I don't really need those parentheses. And what I can do, I've got -2x plus 4 minus 1. On the right-hand side, I can distribute that 1/2, giving me 1/2 x plus a 2. On the left-hand side, I can combine like terms here. So I've got -2x plus a 3 equals a 1/2 x plus a 2. And now you notice you've got x values on both sides of the equation. You can move the 1/2 over by subtracting or move the 2 over by adding. I think I'm going to add 2x over, just so I don't have to deal with a negative. So I have got 3 equals, I got to add 1/2 plus 2. It's 5/2, but in case you need a review, common denominator, I'm going to have to change this 1 to a 2, which changes this 2 to a 4, giving me 5/2. So I've got 5/2 x plus a 2. Now I'm going to be moving this 2 over by subtracting, giving me 1 equals 5/2 x. And now the final step, to get rid of this 5/2, you can divide by 5/2 on both sides. But remember, dividing by this fraction is the same thing as multiplying by the reciprocal. So I'm dividing by 5/2, but that's the same thing as multiplying by 2/5. So I end up with 1 times 2/5, which is just a good old 2/5 equals x. See, we knew that wasn't going to be pretty. But that's just the x value. X is 2/5, or 0.4. Now I got to find the y value that corresponds. So now that I know that the x value is 2/5, I can go all the way up and plug it in for x in either equation and solve for y. I'm going to do it here in this first one because y is already solved for. So I'll have y equals -2 times 2/5 plus 4. Well, -2 times 2/5 is -4/5. When I add this 4, which is understood to be over a 1, I know I got to get a common denominator again. Y is equal to a positive 16/5. So my final answer, my intersection point, is 2/5 and 16/5. If you're looking at decimal forms, you're looking at 0.4, and then this would be 3 and a 5th, so 3.2. And let's look up. We're looking up, and we're going to see if that intersection makes sense. And it looks like it does. If I were to go right 2/5 and up a little over 3, so 3.2, looks like that's my intersection there. So it looks like my math is going to check out. Last thing we need to talk about is horizontal and vertical lines. So if you remember, horizontal lines are lines that have slopes of 0. And they are just horizontal lines. The one I just drew is y equals 1, 2, 3, 4, 5. Y is equal to 5. No matter what x is, no matter what point you go to, for x, the y value will always be 5, so the equation of the line is y equals 5. If I were to draw a line down here, horizontal line here, not exactly perfect. It's y equals -9. Now, vertical lines, they have no defined slope. It's an undefined slope. And if I'm looking at a vertical line, maybe if I look at this one right here, notice at this vertical line, the x value is always equal to 2. The y value changes. It can be anything, but the x value is always equal to 2. So that's your horizontal and vertical lines. And then you remember the equation of a horizontal line is always y equals whatever number you're at. For a vertical line, the equation of the line is x equals a number. And these are considered functions because every input x has exactly one y value. It doesn't matter if the y value is always the same. Whereas if you have a vertical line, these are not functions because you have a bunch of different, all these inputs of, in this example, 2 have a bunch of different outputs of y's. And now at that point, I'm pretty sure that wraps it up. We are all set. We've got a nice little linear review, and you should be all set. And if you want some practice, you can do problems at 2.1. Now it covers both linear and quadratic equations, so the numbers that you can do are outlined here. You can do numbers 1 through 16, 20, and 22 on that problem set if you want some practice.